We are going to continue with our notes for 2.6 rational functions, day 2. Today we want to sketch rational functions. For each equation, we want to determine equations for the vertical and horizontal asymptotes. We're going to abbreviate those as VA and HA respectively, and the points where there are x and y intercepts and holes. We're going to write none if one does not exist. Then we want to complete the sketch. So for our first equation, or our first function, I should say, I have f of x equals 3x over the expression x squared plus x minus 2. So the first thing that's going to be important to us is to get our rational function in factored form. So pause the video and factor the denominator. So now I have the expression 3x over x plus 2 times x minus 1. So I can see that each of these factors is going to cause a vertical asymptote because it doesn't have a matching factor in the numerator. So I'm going to have a vertical asymptote at x equals -2 and again at x equals 1. Next, for our horizontal asymptote, we have to compare the degree of the numerator to the degree of the denominator. So the degree of our numerator is 1. The degree of our denominator is 2. Since the degree of the denominator is greater, we're going to have a horizontal asymptote at y equals 0. Next, we need to decide if there's a slant asymptote. So based on our notes from rational functions day 1, slant asymptotes only happen if the degree of the numerator is 1 more than the degree of the denominator. So in this case, our degree is 1 in the numerator, 2 in the denominator, so we do not have a slant asymptote. Next, we are looking for our x-intercepts. We find our x-intercepts the same way that we used to find them when we were doing quadratics, when we were doing lines. To find our x-intercepts, we let y equal 0. So I have lots of space at the bottom. So this is also what I want to see on a represent part of a quiz or a test. I'm going to label that I'm finding my x-intercepts, and I'm going to let my f of x equal 0. So I want to see when is 0 equal to 3x over x squared plus x minus 2. So this is sort of number sense. People get freaked out because it looks so complicated. The only time this whole expression is going to equal 0 is if the numerator is equal to 0. So we're going to simply solve 0 equals 3x, divide by 3 on both sides, x equals 0. Okay, you don't even have to do this step if you can do, or you don't even have to do the divide by 3 if you could see that x equals 0. So then I'm coming back and I'm writing my x-intercepts as a point, or my x-intercept. So I have the point 0, 0. Now for my y-intercept. This time I'm just going to let so here I let y equal 0. For my x-intercepts, I need to let x equal 0. So when I'm finding f of 0, which is 3 times 0 over 0 squared plus 0 minus 2. And I can see I get 3 times 0, which is 0. 0 over any number is going to be 0. So my y-intercept is the same as my x-intercept at 0, 0. Next, I'm looking for any holes. I think I already said this, but because we didn't have a factor that occurred in the numerator and the denominator, we don't have any holes. So I would write none. So right now I'm going to go in and I'm going to draw, actually, before I start to draw my graph, I want to figure out what's happening on either side of my vertical asymptote. So if I think about this, I'm thinking about my end behavior. So I'm thinking about, or what's happening around the intercepts. So I'm thinking as x approaches -2, so I'm getting that -2 from my vertical asymptote. From the left, I see that I have 3 times a negative, okay, because I'm going to have -2. Then if I'm adding -2 on the left plus 2, I can see that that's also a negative. And if I have -2 minus 1, so what I'm doing is I'm plugging into this expression right here. I can see that that's always also a negative. So if I have a negative divided by a positive, my overall is going to be a negative. So let's see what happens so that means I'm going to -infinity. Okay, on either side of the vertical asymptote, I either go to positive infinity or negative infinity. So if I think of -2 from the right, again, I have 3 times a negative, because my -2, over -2 to the right. We're thinking about -1.9. If I do -1.9 plus 2, I get a positive. But if I do a -2 minus to the right minus 1, I get a negative. So this would be a negative divided by a negative, which means on that side, I go to positive infinity. Okay, at this time, pause the video and do the behavior for x as it goes to 1 on the left and x as it goes to 1 on the right. So I got that to the left of 1, I'm going to negative infinity. To the right of 1, I'm going to positive infinity. You can even start to do this in your head, okay, based on the signs. So now we want to start to graph. So before I start to graph, we have all this information already, but we don't know if we need to change the scale of our graph. It looks like for our x-axis, we can still go from 10 to -10 because we have interesting things going on at -2 and 1 and at 0, 0. But we don't have anything interesting going on in the vertical asymptotes or anything outside of that. So I do want to check if I need to change my y scale. So I'm going into my calculator. Very important, I put the numerator in parentheses and then I divide by the denominator in parentheses. I also put this as my original function, not my factored function, in case I made a mistake. So next, I go into table set, which is second and window. I want to start my table at -10 and have my step be 1. I also want both of my choices on auto. So again, I'm going to hit second, and this time I'm going to go to table, which is above graph. So I see some values. At -10, right? We'll talk about these values in a second. So, sorry, this is what I wanted to do. But I'm going to look at my values from -10 to 10 and see if they go sort of outside of where I need it to be. So my largest value from 10 to 10 is actually 1.5. so it doesn't look like I need to change my scale. So I am going to keep my scale at 10 to negative 10 and 10 to negative 10. When you draw in a vertical asymptote, you draw a dotted line. This is not part of the graph. Okay, but it gives us important information. So there's my first vertical asymptote at negative 2. Here's my next vertical asymptote at x equals 1. I'm going to have a horizontal asymptote at y equals 0. That one's kind of hard to see, so I like to extend it on both sides so that you know it's there. I'm going to plot my intercept of 0, 0. And then I'm going to go and do some of my points. Okay, so at negative 10, I'm really close to 0, which is what I expected. At negative 7, I'm still only about 0.5. At negative 4, I'm at 1.2. At negative 3, oh, these all should have been negative. I apologize. I need to pay attention to my signs. This is why we use erasers. Negative 2.25. Okay, our error at negative 2 shows us that we're right. There is a vertical asymptote. So now I'm going to draw my graph, this branch of my graph. And like we found below, when I'm to the left of negative 2, I should be going to negative infinity. Okay, arrows at both ends. So now I'm looking at negative 1. I'm at 1.5. So again, looking at my behavior when I'm at negative 2 from the right, I know I want to be going up towards infinity. I'm always drawing a smooth curve, and then I'm coming back down as I go to the left of negative 1, which is information that I found below. Again, I see error at 1, which is a good sign. I have at 2, I'm at 1.5. At 3, I'm at 0.9. When I get out to 6, I'm just under a half. So, using my asymptotes, I know that I'm going up to infinity on this side. I'm getting closer to 0 on that side. So this just took me over 13 and a half minutes. Okay, they take time. If they take time, it doesn't mean that you're bad at math. If it takes time, you're making sure you're being meticulous, you're making sure you're being exact. So let's talk about a couple important things on this graph. Anytime you're hitting a vertical asymptote, you absolutely do not want to be crossing it. Graphs can cross horizontal asymptotes. See how this graph crossed? Okay, I would be using Desmos or even my graphing calculator. Let's look at what a graph looks like. Okay, I don't think that's as pretty on my graphing calculator. These are my vertical asymptotes. It's hard to see, so you need to be smarter than your graphing calculator. Okay, and that's why you also need to be able to do all of this on the represent section of your quiz or test. Please come for extra help. This is a lot of steps, but I know you can all do it.